Hello, everyone. This is Professor Ma, and this is the lectures on the dot products and angles between vectors. And these are the things we're going to talk about: the dot products, angles, in unitizing vectors, and orthogonal projections. One of the very important formula is to find the angles between two vectors. And we have two unit vectors. From here on, unit means length 1. So, and suppose theta is the angle between them, then we have this nice little formula that cosine theta is equal to these products in the x coordinate, a times c, added to the coordinates, y product of the y coordinate. And this sum is called the dot product. So here's the pictures. And here, again, we are on the unit circle, so length is 1. And then the cosine theta satisfy these formulas. And this sum is called a dot product. And this basically is just a restatement of the cosine law of the difference between two angles. So if A is the big angle outside and B is a small angle, V, forms V, the standard angle, then theta is going to be A minus B. So cosine theta is going to be A minus B is going to be using the cosine difference angle formula. I get this sum. Okay, so we're going to generalize these to all vectors. So in general, if I have two vectors in two-dimensional space, then this is called a dot product, which is a number. Here are some example of two vectors, UB and their dot products. And if here are some arithmetic, if I multiply by scalar, then the dot product multiplied accordingly by scalar. So if I triple U, then the dot product is triple of the original U dot B. Goes from 50 now become 150. So these are the rules. Basic rules that dot product satisfy. Now, since the formula we had for the go back to the angle formula, it depends on the unit vectors. The length of these vectors, in order for the formula to work, has to be 1. So in general, so if I want to figure out the angle between vectors, then I have to resize them. So, and here's how we resize them. Given a vector, if I multiply a vector by a scalar, then the length of the vector will be the multiple of the scalar. So here, the length is 5 for the vector v. So if I multiply by 10 to the vectors, rescale it, and I get 30, 40, then its length is going to be 50. Okay, if you calculate it through the length formula. In particular, if I multiply by the reciprocal of its length, 1/5, then these vectors has length 1. Okay, and length 1 vector are called unit vector again. The word unit means length 1. And so in this case, if we divide the vector v by its length 5, we obtain the vector 3/5, 4/5, which length is 1. We call it 3/5, 4/5 the unitized v. And here's the pictures. And this is the, in general, how we unitize the formula. We just multiply by the reciprocal of the length or divided by its length, whichever you want to see it. And here is a picture for it, and this is 4/5. And the unitized will be these red vectors. We divide the vector by the length 5. So that will be the unitized. And this unitized vector is also called the unit directional vector, because that's the same direction as v, and its length is 1. And why do we want these vectors? Because the dot product theorems tells us that you can use it to find out the angles between two vectors. So how do we find them? Well, here's how we do it. If we have two vectors that the length is 1, then cosine theta is their dot product. If the length is now 1, we first reduce the size of each vector to length 1. In other words, we unitize it first, and then take the dot product. That's going to be the same angle. Okay, and so this is the formula to calculate the angle between any two vectors, non-zero vectors. Okay, so here's an example to find the angle between these two vectors. Okay, so here is the angle between the two linear combinations, u plus v, u minus v, and the two vectors of some diagonal of some parallelograms, and then the angle between them, you can just go through the formula. Okay. So it's very easy to find the angles once we have these ideas of unitize the vector first, then dot product, then cosine is the dot product of the unitized versions. In particular, one very important theorem is when are two vectors perpendicular, non-zero vector. Well, that's when the dot product is 0, because cosine theta is equal to 0 means theta is 90 degrees. And this is very important. Okay, so here's examples. These two vectors, since the dot product is 0, so they are perpendicular. In two-dimensional space, AB is perpendicular to these two vectors. One of them points, here's vector V and AB, and one of them points this way, one of them points the other way. And so I'll let you figure out, make sure you convince yourself minus VA is the vector V rotate counterclockwise 90 degrees. The other one's clockwise. The other very important things we need to calculate is the shadows of one vector cast onto another vectors. Here we want to cast U onto V. So if we cast a vertical shadow, that we will call projections proj of U onto V. And in particular, if I calculate this product where the theta is the angle between these two vectors, the length of U times this, and then I will get the length of these shadows, but it has a plus and minus sign. And in particular, when the formula calculate cosine theta is positive, then the angle is going to be less than 90 degrees. And then if the theta is negative, then the angle is going to be, that is going more than 90 degrees, it's going to be, the product is going to be negative. Okay. So that's what we call this, this formula gives us the sine length of the shadow. So this formula only gives us the length. This formula right here. Okay. And here's an example how we calculate the length of the shadows. Now, why do we want to calculate the length? Well, actually, in the standard position, I actually want to calculate the shadow vector itself. Here is an example where the shadows cast in the opposite directions, so the angle between them is more than 90 degrees. And so you get a sine length, which turns out to be negative. Okay. Now we come to how do we calculate the angles, excuse me, if the vectors are in standard position, how do we calculate the length of the shadows? Okay. And that turns out to be a very easy dot product because the length of the shadow, remember, is U times cosine, length of U times cosine of the angle between them. But cosine the angle between them was U over length of U, unit vectors, dot V over length of V. And so these cancel, and we're left with these nice formula says, oh, the length of the shadow U onto V is the same as U dotted with the unitized V. So, for example, if I want to calculate the length of the shadows, I take u dot with v, then divided by the length of v. Just u dot with v, and the length of v is rule 17. So that's the length of the shadow. Now, the actuals, of course, what we really want, one more step is what exactly is the standard position of the shadow? That is, what is the coordinate of the tips? Well, and to calculate the coordinate of the tips, we do the following tricks. Again, we take V, we shrink it back to length 1. Okay. And here, let me explain this a little bit. Okay. The sine length of the shadow was u dot with v over the unit vector of v. Okay. Unit size of v is v divided by length of v. Okay. So this, if I put this v on the side as a vectors, and all this is calculated u dot with v unitized v times this v length of v is a scalar, so scalar square, if you like, and this is a number, and then multiply to the vector v. So these are the scalar adjustments to get to the shadows. So this is the calculation going to work. Okay, that's it. That's for these sections. Do the homeworks and see you next time. Have a good day. Bye-bye. Okay, let's turn this up. Stop. Yes.